Welcome, curious mind, to a tranquil journey through the most ancient depths of time. Tonight, we will venture beyond the familiar glow of stars and galaxies, reaching back to an epoch when the universe was fundamentally different, a time veiled in mystery, a canvas awaiting its first brushstrokes of light. This may seem an impossible void to conceive, yet for hundreds of millions of years, this was the reality of our cosmos. This epoch, known to astronomers as the cosmic dark ages, was a period of profound transition, a vast, expanding canvas awaiting its first brushstrokes of light. Our exploration, the hidden truths of time's arrow, what it was really like before stars and more, offers a deep, contemplative perspective on the grand timeline of existence, inviting you to ponder our place within the vast, unfolding cosmic story. Tia. There were no stars yet to ignite, no galaxies to illuminate the void. On the surface, there were only the faintest ripples, almost imperceptible. Our telescopes, no matter how powerful, cannot directly see into this period using conventional optical methods, but as humble, diffuse clumps of gas and dark matter, gradually accumulating under gravity's patient hand. These were the earliest nurseries, slowly preparing the raw materials for the grand cosmic show that was yet to begin. It was a universe pregnant with potential, a vast, quiet stage set for the epic story of stellar and galactic creation. A profoundly dark, yet deeply significant chapter in the hidden truths of time's arrow. Instead, scientists rely on sophisticated theoretical models and indirect observations, such as studying the subtle signatures left on the CMB, or searching for the faint whispers of neutral hydrogen gas from that time. But beneath that surface, the invisible current of gravity was slowly, patiently at work. In the slightly denser regions hinted at by the CMB, gravity began its subtle, tireless task of pulling together the diffuse gas and dark matter. This was an extraordinarily slow process. The universe was still expanding, and the gravitational pull, though constant, was weak over such immense scales. The cosmos was filled with a uniform distribution of neutral hydrogen and helium gas, interspersed with the mysterious, invisible presence of dark matter. While the CMB offered a glimpse of slight temperature variations, the tiny seeds from which future structures would grow, the universe itself was largely featureless, a vast and quiet expanse. Before this point, the universe was a superheated, dense fog of plasma, a soup of free-floating electrons and atomic nuclei. And as it cooled, a pivotal event occurred. The temperature dropped sufficiently for electrons to combine with atomic nuclei, forming the first stable neutral atoms, primarily hydrogen and helium. This event, known as recombination, fundamentally changed the nature of the cosmos. Suddenly, the photons, which had been trapped in the hot plasma, were free to travel unimpeded. The universe became transparent. This released radiation is what we now detect as the cosmic microwave background, the faint afterglow of the Big Bang, a gentle echo that surrounds us even today. Light particles, or photons, were constantly scattered by these charged particles, unable to travel freely. The universe was opaque, like a thick, omnipresent haze, glowing with an intense, uniform heat. Allow your thoughts to settle, your breath to deepen as we gently explore the profound evolution of our universe. From its earliest moments to the intricate dance of galaxies and beyond, let the quiet immensity of cosmic time guide you into a state of profound calm, a state where the boundaries of self and the universe softly blur. Imagine a universe without stars. No twinkling points of light, no blazing suns to warm distant worlds, no galaxies swirling with luminous arms. To truly understand this period, we must rewind the cosmic clock to a moment roughly 380,000 years after the Big Bang. But as the universe continued its relentless expansion, it also cooled. However, even with the universe becoming transparent, it remained dark. Think of it as a calm, incredibly smooth ocean, stretching endlessly in all directions. This era represents a tremendous challenge for observation. Unlike later epochs, illuminated by the light of stars and galaxies, the cosmic dark ages emitted no visible light. These theoretical models paint a picture of protogalaxies slowly forming, not as bright, swirling spirals, but as humble, diffuse clumps of gas and dark matter, gradually accumulating under gravity's patient hand. These were the earliest nurseries, slowly preparing the raw materials for the grand cosmic show that was yet to begin. It was a universe pregnant with potential, a vast, quiet stage set for the epic story of stellar and galactic creation. A profoundly dark, yet deeply significant chapter in the hidden truths of time's arrow. From the quiet, featureless expanse of the cosmic dark ages, we now turn our attention to the universe's awakening, a dramatic era marked by the birth of the first stars and the majestic formation of galaxies. This wasn't a gentle unfolding, but a powerful, almost violent, blossoming of light and structure, a testament to the immense forces at play in the nascent cosmos. Imagine the universe now, hundreds of millions of years after the Big Bang. Within those diffuse clumps of gas and invisible dark matter, the patient hand of gravity continued its work. As more and more matter slowly accumulated in these denser regions, the gravitational pull intensified, drawing gas inwards with increasing force. This process known as accretion, led to the formation of the first proto-galaxies. Imagine two nascent galaxies drawn together by mutual gravity, slowly approaching each other across the cosmic void. At first, they might simply pass through one another, their individual stars rarely colliding due to the immense distances between them. It was a period of immense energy, ceaseless motion, and the profound creation of all the structures we see today, setting the stage for the intricate cosmic cycles yet to unfold. But over millions of years, gravitational forces would warp and distort them, pulling out long tidal tails of stars and gas. Eventually, they would coalesce into a single, larger galaxy. These mergers were incredibly influential, triggering bursts of intense star formation as gas clouds collided and compressed, and often fueling the growth of the supermassive black holes at their centers. Imagine swirling cosmic whirlpools, gradually drawing in more and more material, each one a nascent island of stars and gas. When these colossal population 3 stars reached the end of their brief, intense lives, they didn't simply fade away. They exploded in incredibly powerful events known as supernova. These cosmic detonations were vital, scattered the heavier elements, carbon, oxygen, iron, and countless others, forged in their fiery cores, out into the surrounding interstellar medium. Before these first stars, the universe contained almost exclusively hydrogen and helium. It was these very first supernova that began to enrich the cosmos with the building blocks necessary for rocky planets, and eventually for life itself. As these proto-galaxies grew, they didn't exist in isolation. They were part of a vast, interconnected network, a cosmic spiderweb woven from strands of dark matter and gas. This cosmic web, with its immense filaments and clusters, became the blueprint for the large-scale structure of the universe we observe today. Over vast stretches of cosmic time, these individual stars and their immediate gas clouds began to coalesce into larger structures. The invisible scaffolding of dark matter halos played a crucial role here. These massive, spherical concentrations of dark matter formed during the Dark Ages acted as gravitational anchors, pulling in the surrounding ordinary matter, the hydrogen and helium gas. Like a colossal magnet, the gas began to contract, spinning faster and heating up. In the very densest cores of these collapsing gas clouds, conditions finally became extreme enough to ignite the first stars. These weren't just any stars. These were the population 3 stars, the universe's primordial giants, born from the pristine hydrogen and helium that constituted the early universe. These stars were likely far more massive than our own sun, some perhaps hundreds of times its size. Imagine them as solitary, blazing beacons erupting into existence. Their intense, ultraviolet radiation, finally carving out bubbles of light in the surrounding neutral hydrogen fog. Their lives were brief but spectacular, burning through their nuclear fuel at an astonishing rate, radiating light and heat that began to reionize the universe, slowly lifting the cosmic veil. As these first stars lived and died, their gravitational pull also continued to shape their surroundings. Within these growing dark matter halos, gas continued to fall inwards, forming spinning disks. The birth of galaxies wasn't always a smooth, continuous process. It was often a dramatic and powerful affair, punctuated by spectacular events like galactic mergers. The life of these first stars also had a profound, lasting impact. Thus, the violent poetry of stellar genesis and galactic birth transformed the dark, featureless early universe into a dynamic, luminous tapestry. It was a period of immense energy, ceaseless motion, and the profound creation of all the structures we see today, setting the stage for the intricate cosmic cycles yet to unfold. From the fiery birth of stars and galaxies, we now move to another fundamental aspect of the cosmos, the cyclical nature of cosmic events. The universe, while seemingly vast and unchanging, is in fact a dynamic arena of constant transformation, marked by grand cycles of creation and destruction, evolution and renewal. Yet, even such stability is temporary. When a massive star, many times larger than our Sun, exhausts its nuclear fuel, it cannot simply fade away. Its core collapses under its own immense gravity, leading to a spectacular, violent end. A supernova. These are not just dazzling celestial fireworks. They are cosmic engines of change. They engage in a slow, majestic dance of galactic evolution, often culminating in galactic cannibalism or mergers. Will this grand cosmic clockwork continue indefinitely, or does it have a definitive end? Current theories propose several possibilities, each with its own quiet, profound implications. Our own Milky Way galaxy, for instance, is on a collision course with its larger neighbor, the Andromeda galaxy, and diffuse that all energy dissipates. Stars burn out, black holes evaporate, and the universe becomes a cold, dark, empty expanse. They remind us that our brief span of life on a small planet is nestled within cycles of creation and destruction that span billions of years, a constant cosmic clockwork that shapes everything from the smallest atom to the grandest galaxy. Imagine an infinite, silent void where even light has faded. Imagine two colossal spirals, each containing billions of stars, slowly drawing closer over billions of years. While individual stars are unlikely to collide, the gravitational forces will reshape both galaxies, eventually merging them into a single, larger, elliptical galaxy. What unseen shifts in cosmic ecology might such mergers cause? How do these grand collisions influence the rate of star formation, the activity of supermassive black holes, and the overall distribution of matter in the universe? These are ongoing areas of cosmic contemplation. The two main types, type Ia and core collapse, supernova, though different in origin, both unleash unimaginable amounts of energy, briefly outshining entire galaxies. These cycles, often on scales almost impossible for the human mind to grasp, sculpt the very fabric of space and time. And sometimes they lead to profound, even catastrophic, changes. Gravity would eventually halt its expansion and pull all matter back together into an incredibly hot, dense state, perhaps leading to another Big Bang. Imagine the entire cosmic dance reversing, playing back to its fiery beginning. Imagine a star, much like our sun, living out its long, stable life. A chilling, ultimate dissolution. The impact of these cosmic explosions is immense. Imagine the shockwave expanding outwards, sweeping through vast regions of interstellar gas and dust. This compression can actually trigger new rounds of star formation in nearby nebulae, effectively seeding the next generation of stars. These fleeting, incredibly powerful flashes of gamma rays are the most luminous electromagnetic events known in the universe, releasing more energy in a few seconds than the sun will produce over its entire 10 billion year lifespan. They are thought to originate from the collapse of rapidly rotating massive stars into black holes, or from the merger of neutron stars. While immensely distant, their sheer power raises questions about their potential impact if one were to occur too close to a habitable planet. Could a nearby GRB trigger a mass extinction, stripping away a planet's atmosphere or irradiating its surface? This remains one of the fascinating, unsolved mysteries of cosmic cycles. More profoundly, supernova are the primary cosmic factories for most of the heavy elements in the universe, elements like iron, gold, and uranium. Without these cataclysmic events, the universe would remain a sparse mixture of hydrogen and helium and rocky planets. And indeed, life as we know it would be impossible. So, the death of one star becomes the catalyst for new beginnings. Even more energetic and mysterious are gamma ray bursts. On a grander scale, galaxies themselves are not static entities. These cyclical processes lead us to perhaps the most profound unsolved mystery: the ultimate fate of the universe. One theory is the Big Freeze, or heat death, where the universe continues to expand indefinitely, eventually becoming so vast. Another, less favored, but still intriguing idea is the Big Crunch, where if the universe's total density were high enough, then there is the Big Rip, a more speculative theory suggesting that dark energy, the mysterious force causing the universe's accelerated expansion, could eventually become so powerful that it tears apart galaxies, stars, planets, and even atoms themselves, leaving behind nothing but unbound elementary particles. These theories about the universe's long-term future, though based on our current understanding, remain unsolved mysteries, prompting deep contemplation on the fragility and resilience of existence. They remind us that our brief span of life on a small planet is nestled within cycles of creation and destruction that span billions of years. A constant cosmic clockwork that shapes everything from the smallest atom to the grandest galaxy. From the grand cycles of cosmic creation and destruction, we now turn our gaze towards the future, and a profound question that echoes across the vastness of time: the potential for life beyond Earth, and how the universe's unfolding timeline impacts the very concept of cosmic habitability. Imagine not just where life exists now, but where it could have existed, where it will exist, and how its story is interwoven with the universe's grand, ceaseless evolution. This is the region around a star where conditions are just right for liquid water to exist on a planet's surface, a crucial ingredient for life as we know it. But this zone is not static. It changes as stars age. Stars like our Sun will eventually swell into red giants, potentially engulfing inner planets before shedding their outer layers to become white dwarfs. Could there be forms of life that evolve in conditions vastly different from our own, perhaps thriving in the deep interiors of icy moons, or in the dense atmospheres of gas giants, or even existing at different cosmic ages, sustained by energy sources we don't yet fully comprehend? More massive stars end their lives in spectacular supernova, sterilizing vast regions of space with their explosive energy. The universe is a story billions of years in the making, constantly evolving, ceaselessly transforming. As your thoughts quiet and your breath deepens, may the quiet immensity of this cosmic journey fill you with a sense of peace and perspective. Let the gentle rhythm of time's arrow guide you into a restful state. Good night. Even if our own sun will one day engulf our planet, the universe itself will continue to create new stars, new planets, and new opportunities for life to emerge. We have contemplated the quiet mystery of the cosmic dark ages when the universe was a canvas awaiting its first light. We've witnessed the fiery birth of stars and galaxies, a testament to the universe's dynamic and creative power. We've explored the grand, often cataclysmic, cycles that shape the cosmos, from the death of stars to the fate of galaxies, and pondered the ultimate destiny of our universe. And finally, we looked forward, contemplating the endless unfolding of time and the potential for life. Across countless worlds and through unimaginable cosmic epics, life itself, in this grand cosmic view, is a product of cosmic time, a continuous thread woven through the universe's endless unfolding. The echoes of the future are not just about what lies ahead, but about the enduring potential for existence to adapt, evolve, and persist within the universe's vast and ancient embrace, offering a quiet assurance as you drift towards slumber. These stellar life cycles dictate the windows of opportunity for life to arise and thrive around different types of stars. A planet might be born habitable, but its star's evolution could render it uninhabitable over cosmic timescales. Our sun, for instance, is slowly growing brighter and hotter. Billions of years from now, Earth will likely become too hot to sustain liquid water. This means the habitable zone around a star shifts outwards over cosmic time, implying that a planet that is habitable now might not be in the future, and conversely, worlds that are currently too cold might become habitable as their star evolves. This continuous shift across billions of years adds a dynamic layer to the search for life. Our understanding of planetary systems has been revolutionized by the discovery of thousands of exoplanets, worlds orbiting stars beyond our sun. These could be gases like oxygen, methane, or ozone, which on Earth are largely produced by living organisms. Imagine a distant telescope patiently collecting the faint light from an exoplanet, then splitting that light into its constituent colors to reveal the subtle chemical fingerprints of life. It's a painstaking process, but one that holds the promise of the most profound discovery imaginable. Each new detection expands our cosmic imagination, hinting at a staggering diversity of environments. Scientists employ ingenious methods to find these distant worlds, such as observing the tiny wobble a star makes as an orbiting planet tugs on it, or detecting the subtle dip in a star's brightness as a planet passes in front of it. Each method is like a faint whisper across interstellar space, revealing the presence of unseen companions. The concept of a habitable zone is central to this search. The search for life on exoplanets also involves looking for biosignatures, chemical indicators in a planet, as atmosphere that suggests the presence of biological activity. Beyond the shifting habitable zones, we must also consider the long-term evolution of stars themselves and their profound impact on planetary habitability. This concept leads to fascinating questions. Could life have evolved, flourished, and then vanished on countless worlds throughout cosmic history, long before humans ever looked to the stars? The possibility of life arising and persisting in different cosmic eras, across billions of years of unfolding galactic history, offers a sense of hopeful continuity. As our journey through the hidden truths of time's arrow gently concludes. Allow your mind to drift back from the profound depths of cosmic history and the vastness of the universe's future. These profound insights into cosmic time remind us of our own fleeting yet precious place within this grand narrative. The universe is a story billions of years in the making, constantly evolving, ceaselessly transforming. As your thoughts quiet and your breath deepens, may the quiet immensity of this cosmic journey fill you with a sense of peace and perspective. Let the gentle rhythm of time's arrow guide you into a restful state, a profound and tranquil sleep. Good night.